Hello. My name is Ashley McNamara, and today I'm going to teach you how to code like you belong on the Go team. But first, a little bit about me, Ashley McNamara. I work in Microsoft Azure as a cloud developer advocate. I work with amazing people like Brian Ketelsen. On Twitter, I'm at Ashley McNamara. On GitHub, Ashley McNamara. And my most popular repository is Ashley McNamara/Gophers, where you can find copies of all of the Gophers that I draw by hand for the Go community. So please enjoy yourself and go to Ashley McNamara on GitHub/Gophers, and you can print your own stickers and posters. They're all liberally licensed. This talk is available at cda.ms/littlej-big-P. I want to take a moment, though, and talk about a person that's very important to me, a person that's been an inspiration to me, a person that I love very much. Brian Ketelsen is an amazing person. I don't think I could be Ashley McNamara without Brian Ketelsen. He's handsome. He's smart. Amazing. So thank you, Brian. Thank you. So to write code like the Go team, we're going to talk about several points. We're going to talk about how to organize your Go code into packages and what those packages should contain. Many times that's a problem for new Go developers. What code goes in which package? How do we know? We're going to talk about code patterns and conventions that are prevalent in the Go standard library. We'll talk about how to make your code more clear and understandable. And we'll talk about unwritten Go conventions that go beyond Go format and make you look like a veteran contributor to Go. So, our outline, we're going to talk about packages, naming conventions, and source code conventions. Let's start with packages. There are two key areas of code organization in Go that will make a huge impact on your usability: the testability and the functionality of your code. Those two pieces are the package naming and package organization. If you've ever seen a large Go project that has 100 files in one package, that's not usable. Conversely, when new developers come from Java, sometimes we have 1,000 packages, each with one source file. That's also not good. Where's the middle? So we can't talk about code organization and naming separately. It's one problem. We talk about them together because that's what makes sense. How's my hair? Did I do it right? It gets in my eyes. So a package should contain code that has one purpose. When you look at the standard library, this is a list of some of the packages in standard library: archive, crypto, errors, index, math. One purpose. When you look at the archive package, do you think that you can find the constant for pi in there? 3.141599726 whatever? Do you think pi is in archive? No. I think zip tools are in archive. I think you can open a tar file with archive. And it's very clear by looking at the package name what that means. Sometimes you have a group of packages that do the same thing. In standard library, a perfect example of this is the encoding library. We have to encode JSON, XML, ASN1, base64, base32, hex, and so many more. So it makes sense to have a parent package called encoding, and in that parent package encoding, there's an interface that all of the children packages implement. So we've done two things. We've defined a clear interface for all things that have to encode, and we've made a very clear convention that all of the children packages under encoding are part of that package. So using the standard library as an example, the encoding package shows us how to take common functionality and group it together in a set of packages. So some of the commonalities of well-organized packages. The package names always describe their purpose. Does a package named utility describe its purpose? No. It's very easy to see what your package does by looking at the name of the package. The names of the package in the standard library are always short. You don't see 50-character names in standard library. They're usually 6 or 7 characters. One small word that describes what the package does. Archive. We could have called it zip and tar things, but archive is smaller and more clear. When necessary, we use a descriptive parent package and several children implementing the interface in that functionality, like the encoding package. So the packages that we've seen so far are all libraries. They're intended to be imported by someone else's code. You build libraries so that you can share them and use them in your commands. But when you're writing an executable program, a command or a service, how do you organize those packages? Let's look at that next. So when you have an application, the package organization for that application is just a little bit different. The difference is that the command, the executable that you're building, ties all of those dependent packages together. So what we want to do is create an organization structure that makes sense for something that has a lot of dependencies. So application packages have a huge impact. The way you organize them has a huge impact on the testability and the functionality of your system. Oftentimes when people ask me questions about, oftentimes when people ask Brian questions about how to test code, if they have a problem with testing their code, many times Brian will tell them that it's because their packages are incorrectly organized. If you're having a problem creating a test, it might be because your packages don't make sense. And that's usually the first sign to Brian that there's a problem with your code organization because it's harder to write tests. He's such a smart guy, that Brian. When writing an application, your goal should be to write code that's easy to understand. That's probably my #1 favorite feature of Go. I can look at Go code and understand what it's doing. When Brian wrote C# for 10 years, and today when I look at C# code, I don't understand it very well at all, because Go has spoiled me so much. You can read Go code and understand what's going on. Your packages should do the same service for your users. It should be easy to understand what your application is doing by looking at the packages. So most libraries focus on a single function. The archive package focuses on making and reading archives. That one function is important to the package, but when you have an application, a command, a microservice, it uses lots of libraries. So it ties all of those smaller libraries together, and that means that the scope of the packages in your system are much larger when you build an application. So when you build an application, you should organize the packages in that application into 2 categories: domain types and services. Domain types are the types that model your business functionality. So if I worked at Google, for example, a domain type might be a search. We might have a type that represents a search that a user entered. That's a domain type. If I worked at a telephone company, A domain type might be a call record. Or if I work in an HR department, hiring and firing people, that'd be fun, then maybe one of my domain types might be an employee. So domain types are the things that model your business functionality. Services are the packages that operate on or with your domain types. There's a fantastic article written by Ben Johnson on medium.com about laying out package definitions for applications. Strongly recommend you read this. Remember, you can get the URL cda.ms/j_big-P, and it's much easier than trying to take a screenshot of this slide. I saw you over there. So domain type is the substance of your application. If you have an inventory application, your domain types could be product or supplier. HR administration system, you've got employees, departments, business units. The package that contains your domain types should also very clearly define the interfaces between those domain types and the rest of the world. So I have an employee. What are the things that I need to do with an employee? So maybe we have a domain type called employee and an interface called employee saver. And it tells us that we expect to be able to save this employee to some database. Those should be together, and they should be in the root of your application, a root folder, because when you open that package on GitHub or in your code editor, you want it to be clear what this application does. And you can do that by opening the employee.go file, seeing an employee type, and then an employee interface, employee saver. I already know what the app does. It's right here. It's written right in the root of the package. So domain types should be in the root package of your repository. That makes it clear to anyone who opens your code base for the first time what domain objects we have and what things we want to perform with them. The domain type package or the root package should not have any external dependencies. I'll say that again. The domain type or root package should not have any external dependencies. It's a roadmap for your application. It tells you what and how. That's it. It only exists for the purpose of describing your types and their behaviors. The implementations of your domain interfaces should be in subdirectories, separate package, and they should be organized by their dependency. For example, I said that we had an employee domain type and an employee saver. So we could create a sub-package or a package underneath our root called Postgres. And under Postgres, we have an implementation of the employee saver for the Postgres database. What we've done is declared in the root level what we're going to do, and then in the Postgres package, how we're going to do it, and we already know which database we're using because the package name is Postgres. So with all of your external dependencies, if you create a single package representing that external dependency, whether it's Postgres or Memcached or MongoDB if you want to throw your data wherever, you have choices, and putting all of those dependencies together by interface type will make your life simple when you're creating tests. So, what are dependencies? Dependencies are external data sources. Maybe you're making an HTTP call out to another system to get data. Maybe you're making a call out to another microservice in your company. They could be more complex things, like transportation logic. In our root, in our domain types, we determine the domain type and the services that they provide, but there was no explicit declaration that we were going to provide that service over HTTP. Maybe you want to use HTTP and REST services today, but tomorrow you want to use gRPC. So don't declare the type of service, or the transport of that service in your interface. Save that for an implementation. And there should be one package per dependency. So why one package per dependency? It makes testing so much easier. When you have an interface that defines how to save an employee, and then you have a package called Postgres that actually saves the employee, when we want to test that, all we have to do is create another version of that interface that saves it to disk instead of saving it to the database, or saves it to memory instead of saving to the database. Often people call that a mock. But more importantly, you're using a form of dependency injection, because you determine at runtime, or compile time, how you're going to satisfy the domain interfaces that you've created. With one package per dependency, you can very easily switch dependencies to something different. If today Postgres works for you, but tomorrow Postgres isn't enough, you can move off to Azure Cosmos DB or MySQL. The most important part of one package per dependency, though, is the last point: no circular dependencies. If you have a package that depends on another package, and that package depends on the first package, the compiler doesn't know what to do. That's a circular dependency. And you can get into circular dependency trouble when you start mixing domain logic with interfaces for your services. So if you use one package per dependency, you'll almost never end up with circular dependencies. And for me, that's the best reason to do all of this. So let's talk about some coding conventions. My favorite quote: there are two hard things in computer science: cache invalidation, naming things and off by one errors. Naming things is very hard. It really is. But if you put some thought into how you're going to name your types and your functions and your packages, those package names and type names and function names will make your code more readable, more understandable. Remember, you spend maybe 20% of your time actually coding. The other 80% of it is reading the code that you've already written or code that someone else has already written. Go is so helpful because it's optimized to be read easily. We could make Go look like Scala if we wanted to, but nobody's that mean. Instead, we want Go to be readable. So if you choose package names and function names and type names that are easy to read and very descriptive, then you've helped your future self and your coworkers. So a package name should have the following characteristics. It should be short. That's pretty simple. Prefer transport over transport mechanisms. Small word, descriptive word. Your package name should be clear. You should name it for clarity based on its functionality. The bytes package in standard library, perfect example. We know what we're doing in the bytes package. We're manipulating bytes. You should also name it to describe the implementation of an external dependency. So if we have code that works with Postgres, I think Postgres is a really good package name for that code. Because it's an implementation of a domain type, we already know about the domain types. What we care about in this package is how that domain type talks to Postgres. So Postgres is a perfect package name. Packages should provide functionality for one and only one purpose. Avoid catch-all package names like util, helpers. How many people have a util package in their Go code right now? All right, now Brian this morning said there were a lot of liars in the room. I need to see more hands. Because I've seen a lot of util packages out there. And that is a code smell. A util package tells you that you might be missing an interface somewhere. Think about it. If you've got util convert to thing, doesn't that maybe mean that you should have an interface called thing converter? And then you can get rid of the util package. Often these util packages and catch-all packages are the first place that you run into problems with circular dependencies. If the domain type depends on the util package, because we need to know how to convert it, and then the Postgres package depends on the util package, because we need to know how to convert it, now you have a circular dependency. What's the answer to that? Is it to make one more package or delete one package? Delete. I want you all to go home and delete your util packages tonight. So variable naming. If you look at the standard library in Go, there are some very clear patterns for variable naming. Go code uses camel case, not snake case. Go code very often, almost always, uses a single letter to represent indexes. Usually that single letter is I for the first one, J for the second one, and K for the third one. You use short and descriptive names for other variables, like count and cust. It's very clear what a count is. It's not so clear what C is. C, the letter C for customer, is too short. Customer is pretty long. Cust is a good medium point. Just remember that there are no bonus points for making your code hard to read. I've seen developers use one-letter variables for everything in a 1,000-line package. Can you read that code? I don't want to read that code. Use a variable name that's long enough to understand and not so long that you don't want to type it. It's a good middle ground. And if you use the scope of the variable as your guide, then you can determine how long it needs to be. In your code, if you declare a variable on line 1 and you use it on line 3, you can use a really short variable name because those 2 lines of code are this far apart. But if you declare it on line 1 and use it on line 200, you better use a long variable name because I don't want to have to scroll all the way back up to the top of the package to determine what that variable is. So the farther away your code use is from the declaration, the longer the name should be. This is something that surprised me looking at the standard library in Go. Many times when there's a collection or a slice of something, they use 2 letters to represent that collection or slice. So if we have a collection of things, a slice of things, they'll use TT as the variable name for that slice. And then when iterating over that collection in a loop, they'll use a single letter T. So TT is many, T is 1 inside the loop. It makes it more clear what you're dealing with. When you see 2 variable names that are the same together, TT, this has to be a slice or a map or something. We know it's a lot of them though. And a single one inside the loop, we know we're looking at 1 instance. Avoid package level function names that repeat the name of the package. An example, good example is log.info. The package is log. We already know our intention because the package is log. We know we're logging. So if we have log.loginfo, we're just repeating ourselves. Get rid of the extra, log.info. Package name already declares the purpose of the method, so there's no need to repeat that. Who came from Java? .NET? C#? Java? There is no getters, there are no getters and setters in Go. No. If you write mypackage.getCustomer, mypackage.setCustomer, I might laugh at you. And more importantly, your code won't look like it was written by a veteran Go developer. So get rid of anything that says get or set. This one's tricky. So if you have an interface and it only declares one function, add ER to the end of the interface name to make the name of your interface, or add ER to the end of the function name. So in this case, we've got one method called string. So the interface name is stringer, and that's an English idiom that makes it look like this interface does something. Stringer. This is a thing that makes strings. I don't know if that translates well to Russian. Somebody can tell me later. Now, here's where I disagree with that. If you have a larger interface that declares more than one method, it doesn't make good sense in English to add ER to everything. And the Go team may disagree with me on this, but I'm standing strong because I'm Ashley McNamara, and damn it, I know what I'm doing. So the customer storage interface, we could have called it customer saver, customer databaser, but that doesn't make sense. It's a customer storage interface. It's okay not to use that ER everywhere. Let your own logic, and more importantly, the readability of the code, guide your choice. I just made this point. There are purists out there, Go team, that think all interfaces should end in ER. It's okay to break this rule. So inside your package, separate your code into logical concerns. This is pretty obvious for most Go developers now. If you have a type called an order, then you put the orders type and the orders interfaces in orders.go. So everything related to this domain type in one file. It gets frustrating if you have a type called orders in orders.go, but the interfaces for orders are in orders interfaces. And then later somewhere else you've got a orders interfaces impl.go. No, one file. In the package that defines your domain objects, define the types and interfaces for each object in the same source file. So orders.go contains both the type and the interface. Here's a smaller tip that makes a huge difference, and it's something that I didn't really realize until much later after I started Go. In your comments, make your comments full sentences that end in a period. It's a silly, tiny thing that makes a huge difference in the readability of your code. When you have full sentences that form full paragraphs, your code comments look like documentation, which is funny because that's what your code comments are in Go. They're documentation. So take care and use concern when you write comments in Go. Make full sentences. Make it readable. Make the next person who reads this understand what's going on. Go imports. I think I know who wrote Go imports. Who was that? Brad. Brad wrote Go imports. Use Go imports, please. It's a great tool, and the most important thing that Go imports does, it orders your dependencies in the same order every time. It puts standard library at the top in alphabetical order, and then all of your other external dependencies below it in alphabetical order. There is nothing more frustrating than having your editor report that you have a variation in a file when you're trying to make a commit, and the only difference is the order of your imports. If you use Go imports, you'll never have that. This one's big. Avoid the else clause. You can almost always, not always, but almost always skip having an else clause if you write your if statement correctly. And this makes code so much more readable. So we have if error is not equal to nil, handle the error, and return. The else is implied. There is no else because we're returning in the bad case, and we're just continuing in the good case. So most if statements can be written so that you don't need an else. And that makes your code much more readable. So if you follow these conventions, it will make your source code easier to read, easier to maintain, and easier for someone else to understand. And I think those three things are the things that we strive for most as developers who worry about the future. If you don't care about the future, if you don't like your coworkers, ignore the speech. Or if you hate yourself, I don't know. If you have any questions, feel free to ask Ashley McNamara. Thank you very much.
So well, Ashley, are we going to have some question session right now?
Sure, I'll answer anything.
Okay. And we have one Gopher for the best questions.
Okay.
Hello, Brian. My question will be about utils, but they are so damn useful. For example, there is common occurrence in our code base is generate UAD packet, UAD string, and it's merely a wrapper function which just prevents the panic from occurring. And this seems extremely it's painful to create another package called UAD to place UAD.go and to place generate string inside that file. So, and there's a lot of these examples in the code bases, I'm sure.
So let me answer your question with a question. You hire a brand new developer right out of college, and they need to fix the UUID function. Where are they going to look first? Are they going to look in a package called utilities and other crap, or are they going to look in the package called UUID? It's all about readability.
So we are spending verbosity and expense for. We are getting readability and expense for verbosity. So we are creating more packages.
Perhaps you're creating more packages, but my argument is that that gives you better readability.
Even if it means creating one package for one function.
Yes.
Thank you.
You bet.
Ashley? Thanks, it was great. My question about large interfaces. You said about interface that has 3 methods, save, delete, and so on. So I have a controller that have any actions. Anyway, do you think was it good to have a large interface that may
I think I understand what you're asking. The Go convention is to have very small interfaces. But is it okay to have a big one?
Yeah.
Yes, I say that if you're writing the standard library in Go, then you should have 1 or 2 methods in your interface. But we generally don't write the standard library in Go. We're writing business applications to solve problems. And I have written interfaces that have 60 or 100 methods because it's one type and one dependency.
But if we have a problem with testing, I should implement a mock for this large interface. So what to do?
It's never easy to test something with lots of functions, but if that dependency that you're using, say it's a database, if all of those methods are in one interface, it's because it's one dependency. So use something like GoImpl, G-O-I-M-P-L, that generates your mocks for you, because that makes your life a little bit easier.
Thank you.
Sure.
Oh, Ashley, may I ask? First question, how do you handle your util package if it has a lot of functions, like 50 maybe?
So if you have a package called util that has 50 functions in it,
Yes.
I would say that you're writing code that's hard to test. And you should look at those functions and determine whether they can be moved into interfaces for the domain types. So what is the relationship between those 50 functions? What do they share? They probably don't share anything, do they?
Yeah.
You just,
Al-
what they
almost
share
always.
is that you didn't know where to put them. And that's not a good reason to name it util. So
Okay.
try to find the commonalities and take some of them and put them together into their own packages by business function, by functionality.
And the second question, by the way, do you have a boyfriend?
I look,
Do you have a boyfriend
do
right
I,
now?
I cannot answer that question publicly. I might have more than one boyfriend and I don't want them to know.
Thank you very much.
And that's the best question.
So, thanks. Коротенькое объявление, ребят. Кто-то потерял телефон. Вот, подойдите, потом заберите.
I thought he was asking questions.
We can do one last question.
Okay, one last question.
Yeah.
Okay.
That's not fair. He can't know whether he oh,
Two
there's more to go
questions.
for.
Okay, two questions. This one and this one.
Okay.
Okay. Small questions about getters. Common problem you have struct with thing field, and now you have another implementation with thing field, and you're going to expose ability to get thing through interface. How I should name method of getting thing if not get thing?
You should just name it thing.
I have
And
already
make-
thing field, so I can't.
So if you have a method already called thing and it doesn't return a thing,
I have a field that.
you have a
thing.
you have a thing field in your struct. But you want to return a thing as well? Why does it have to
yes,
be? Why can't you just return the field? Unless you're using gRPC. That's correct. They can't be named the same way. But my question is, if you want to return thing, because it's the thing you're asking for, then return the field. Just get the field. And if you need a different method so that you can change thing before you return it, then name your method changed thing. For example, uppercase thing, lowercase thing, or rounded down thing. Because if you have to have a method for a field, then you're making a change to that field.
I need to have a method for a field because I want return struct as interface. I can't get field through interface.
So you want to use your struct to implement an interface.
Yes.
I don't have an answer for you. I think the answer is ask them to change their interface.
Okay, and the last question here.
Thank you for your speech. My name is Max, and my question may sound provocative, but I hope for the fair answer. And the question is, what do you think about international identifiers in Go?
What do I think? Sit
About
loud.
international identifiers, like using UTF characters to name the things in Go code, like types and variables, because like I think I've never seen Russian in Go, but I definitely seen Chinese and Japanese.
Yes.
So what do you think about it?
I think that if most of your developers use those languages, then that's perfectly fine. But the problem is that Go's exported naming requires a Latin character for the first letter. So I've seen Chinese code bases, for example, where they'll make capital X and then a Chinese variable name, or lowercase x and a variable name. If that works for you and that's readable, then that's fine. It's not Latin. What is it, UTF-8? Unicode uppercase. Thank you. Good.
Yep. Thank you, Ashley.